Vaporization. Welcome to the second part of the heat series. In this video, you're going to learn about the various effects of heat, the changes of various states, and also about thermal expansion. So, without any further delay, let's soar the sky. Heat produces various effects on the body when it is kept continuously for a considerable period of time. There are basic two effects that heat energy produces. The first is the rise in temperature, and the second, it is also the cause of the fire. The first effect of heat is the rise in temperature. If a body is kept continuously on heat energy for a considerable period of time, slowly and gradually the body will have a rise in temperature. There will be a steady rise in temperature. This we can very easily measure with the help of any kind of thermometer at our home. This can also be seen when this heated body is kept in contact with any other body with a normal room temperature. That heat gets transferred from the heated body or the body of higher temperature to the body of colder temperature, as we have already discussed in the previous video. So this can also be observed with the help of a thermometer. If we check the temperature of both the bodies, we will see the hot body is losing temperature and the colder body is gaining temperature from time to time. The second effect of heat energy is fire. Now, if a body is heated for a long period of time, a time comes, if that is a flammable body, that body might catch fire. This happens differently for different flammable objects. For example, kerosene, petrol, a piece of paper, those catches fire immediately after getting a considerable amount of heat. While a piece of log wood takes quite a longer time than these materials to catch fire. This depends on how much flammable the material of the body is. The time taken by the body, by the flammable body to catch fire depends upon how much flammable that particular body is. There is a separate effect of heat energy that requires a special and separate mention. So, what is it? It is the change of state. Now, let me be very clear with you, my dear students, that every matter as we know it has three particular states, mainly solids, liquids, and gases. Heat can let these states interchange between each other. There are several processes involved in those changes of states. Those processes are as follows: melting, freezing, vaporization, condensation, and sublimation. Now we will go deep into each and every process and how heat enables change from one state to another. Let's talk about the first process related to the change of state, or you can also call it the first change of state, that is from solid to liquid, and the process that involves this is called melting. So what is melting? The process by which a solid changes into its liquid state due to the application of heat is called melting. So the process by which a solid changes into liquid state due to heat is called melting. This is the definition of melting. Now you would wonder that this must be happening at a particular specific temperature from one state to another. Say for like solid to liquid it is changing, there must be a specific or particular temperature involved in it. Yes, there is, and that is called the melting point. So what is melting point? The particular temperature at which a solid gets converted to a liquid is called melting point. Say for example, the melting point of ice is 0 degrees Celsius. At 0 degrees Celsius, the ice starts melting and gets converted to water. When we take out the ice tray from the freezer and it is brought into the room temperature, it immediately starts melting because the room temperature is way higher than 0 degrees Celsius, where its melting point is just 0 degrees Celsius. And you should also keep in mind, during the process of melting, the solid is gaining heat to change into the liquid state. Ice is gaining temperature or heat and it is changing into water. There are also other change of states where the body might lose heat to change into any other state. That is all about the next process, which is freezing. Freezing is exactly the opposite of melting. In melting, the solid was getting changed into the liquid state. In freezing, the liquid gets changed into the solid state. And this is the second change of state that we are talking about. So what is the definition of freezing? It is the process by which a liquid changes to a solid state by losing heat, by giving up heat, just opposite to melting, where it was gaining heat to change into some other state. So here, by losing heat, it is changing to a solid state, and this process is called freezing. Now again, it must be happening at a particular temperature, which is the freezing point. The particular temperature at which the liquid gets converted into a solid state is called the freezing point. For example, the freezing point of water is also 0 degrees Celsius. That is, water at room temperature needs to lose heat from that 35 degrees Celsius to 40 degrees Celsius. It needs to lose heat so that its temperature falls to the level of 0 degrees Celsius, and then it starts to freeze, convert to ice. How we can see that? If we put an ice tray filled with water inside the freezer, after a certain point of time, if you pull out the tray from the freezer, you will find thin sheets of ice forming on the surface of water. If you puncture them, there is still water inside. That means it has started to freeze. It's not yet frozen completely. So at 0 degrees Celsius, water starts to freeze from its state of water, that is liquid state, to ice, that is solid state. The next process of the change of state is vaporization. What is vaporization? Now, if we supply heat continuously for a period of time to a liquid, at some temperature, it will slowly and gradually start converting or changing into a gaseous state, or it will start to form vapors. Okay. This entire process is called vaporization. So what is the definition of vaporization? The process when heat is supplied continuously to a liquid at a particular temperature, it will start to change into gaseous form or state, and it will also form vapors. This process is called vaporization. Now, vaporization can be divided, or it is divided into two parts. In two ways you can call it vaporization might occur. The first way is boiling and the second way is evaporation. Now let's see what are these and what are the differences between these two processes when both of them converts a liquid to its gaseous state. The first form of the conversion of a liquid into its gaseous state, that is the first form of vaporization, is boiling. Now listen very carefully. What is boiling? When a liquid changes its state into hot vapors or into a hot gaseous state, you can call it, after crossing a particular temperature. After it crosses a particular temperature throughout its body, it is called boiling. So the process of boiling occurs throughout the liquid, from the top to the middle to the below. Throughout the liquid, the process of boiling occurs, and it only happens after crossing a particular temperature and throughout its body. So this is the definition of boiling, that is when a liquid changes into hot vapors or into a hot gaseous state after crossing a particular temperature throughout its body. It's called boiling. Now obviously, what is that temperature? That temperature is boiling point. That is the particular temperature at which the liquid forms bubbles throughout. If you boil water, you can see the bubbles are formed throughout the body of the water. So throughout the body of the liquid, bubbles are formed and it gets converted into a gaseous state. That temperature is called boiling point, and the boiling point of water, as an example, we can say is 100 degrees Celsius. Before 100, you can find small tiny bubbles forming on the surface, but that is not boiling, mind you. For the water to reach its boiling point, it has to form bubbles throughout its body, and then only it will reach the 100 degrees Celsius mark and it will readily form hot vapors. The next process by which a liquid can get converted into a gaseous state, or the next process of vaporization, is evaporation. Now, what is evaporation? It is a very slow process if you compare it with boiling. Boiling happens instantly and requires a lot of heat. Evaporation is a considerably slower process and it can occur by getting way lesser heat than boiling. Okay, so what is the definition of evaporation? It is a slow process, a process of slow conversion of a liquid into a gaseous state below the boiling point. It doesn't even requires to reach to the boiling point. It is called evaporation. And another thing to be kept into your mind, which is a very important point, it occurs only at just the surface of the liquid. It does not go beyond the surface. It occurs only at the surface of the liquid. Say for example, during the hot summer days, the ponds, the rivers, all are exposed to the harsh rays of the sun. So slowly and gradually the top level starts to get evaporated and form vapors, and these vapors only ultimately form clouds, and during the monsoon these clouds become so heavy with moisture they fall down as rains, as we have already studied in the lower class as water cycle. So this is how evaporation occurs, and it also plays a significant role in the water cycle that occurs in nature every day. The fourth change of state is condensation. What is condensation? The process by which a gas changes its form into a liquid by losing a considerable amount of heat is called condensation. So the definition for condensation will be the process by which a gas changes into a liquid state by losing heat is called condensation. Now, there is a particular temperature at which the gas starts losing the heat and starts to get converted to the liquid state. That temperature is called condensation point. What is condensation point? The temperature at which a gas starts to convert or condense into a liquid state is called condensation point. For example, water has the condensation point of 100 degrees Celsius, which is also equal to its boiling point. Now, water vapors which are extremely hot, which can only be formed after reaching a temperature of 100 degrees Celsius, that hot water vapor, those needs to get cooled down. When they get cooled down or condensed, if we want to cool down water vapors, we have to bring it down from 100 to the lower temperature. So the 100 degrees Celsius is the mark from where that water vapor will start to lose heat and go down and slowly and gradually condense into or get back into its liquid state, that is water. Condensation is very easily seen all around us. I can give you a very good example. When the water evaporates after reaching a particular temperature during the hot summer days, it forms water vapor and the airs start to gather it. But when the air gets cooled down, it loses heat. It does not have the required amount of heat to carry those water vapor. So slowly and gradually, those water vapor inside that cool air starts to condense or go back to its liquid form, that is water droplets. These are present in the air in the form of miniature water droplets, and when the temperature is considerably cooler, we can find it in the form of dew drops in the early morning. The last but not the least of the processes involved in the change of state is sublimation. What is sublimation? It is a very weird process. Here, a solid gets directly converted into a gas without going through the intermediate state, that is a liquid. So what is its definition? The process by which a solid gets converted directly into a gaseous state without undergoing through the liquid state is called sublimation. The very easy and basic examples would be naphthalene balls, which we keep inside our wardrobes to keep our clothes fresh, especially during the days of damp, that is monsoon. So naphthalene balls and also camphor, kapoor we call in Hindi. You have also, I think, seen kapoor being burnt during the offerings, during the prayers, during the pujas. Kapoor also, like naphthalene balls, if kept for some time in the room temperature, will slowly get converted into a gaseous state directly. They won't have the intermediate liquid state while getting converted. The next topic is thermal expansion. Now, before we go into what is thermal expansion, let me be very clear with you regarding certain things. We all know that matter exists in three forms, that is solids, liquids and gases. And the intermolecular configuration inside each type of matter is different. In solids, the molecules are packed extremely tightly, very closely together. There is almost negligible intermolecular space in between the particles of a solid. Liquids have a little bit of more intermolecular space. They can move a little bit, so that they are also termed as fluids, as they can flow. And last but not the least, the gases, they have large molecular spaces, intermolecular spaces in between them, so that they can move and flow around very, very easily. So, due to this difference in the molecular arrangement of the solids, liquids and gases, if we heat them separately, we will be able to see that they will expand. Why? Because one thing, if you have read as the kinetic theory of matter, that inside every matter, whether it's a solid, a liquid or a gas, inside every matter, the particles or the molecules are in always constant random motion. They are trying to move, and if we supply heat, which adds as a fuel to that motion, because it's another form of energy and we are increasing the energy inside that particular matter, so they will start to move faster. Now, due to this push of the molecules to move apart from each other, due to the application of heat, leads to the expansion of the matter. Now, due to this difference in the molecular arrangement of the types of matter, this expansion will vary in solids, liquids and gases. They will have separate types of expansion. This is what thermal expansion is. The expansion that occurs due to the application or gain of heat is called thermal expansion. So let's give a quick look to the definition of it. The phenomenon of expansion of solids, liquids and gases due to heating or gaining of heat is called thermal expansion. So thank you for watching this video. If this video has been helpful to you, please go ahead and subscribe to our channel.